Hi, welcome to the final part in mechanical and sound waves. This is indeed a very long chapters. Now, we are going to learn about Doppler effect. Okay, Doppler effect. The Doppler effect equation is this. The observed frequency, F naught, is equal to V plus minus velocity of observer divided by V plus minus velocity of the source multiplied by the source frequency. Okay, so FO is the observed frequency, or we call it apparent frequency. It has two names, observed frequency or apparent frequency. So same meaning, yeah? And Fs is the source frequency or the actual frequency, yeah? The frequency that actually emitted from the source. And observed frequency is the frequency that is heard by the observer. Okay, not the frequency emitted, but it's the frequency that is observed by another observer nearby. Okay, so and V is the speed of sound. Okay, speed of sound is constant. Okay, given in the questions, normally is 343 meter per second. That is V. And velocity of observer is always at the top. Yeah, velocity observer is at the top. Velocity of the source is at the below. So you must be careful. Velocity of observer is at the top. Velocity of the source is always at below. You must be careful with the sequence. Okay. So there are actually 4 situations we need to take note in Doppler effect. Okay. These are the 4 situations. Do you see that? It's either between the source and observer. Okay, we only have these 4 conditions, and at all times in our syllabus, one of the parties must be stationary. It's either the observer stationary or the source stationary. Okay. So only one person moving, either the source moving or the observer moving. The first 2 situation is the source moving. The another 2 situation is the observer moving. So look at the first 2 situation. If the source is moving towards the observer, and this is the waveform. I can see the wave is more compressed. So the wavelength becomes smaller. Because when the source is moving towards the observer, this wave is emitted by the source. When the source is moving towards the observer, the wave normally is compressed. So the wavelength becomes smaller. Okay? And the frequency heard by the observer, the wave will reach the observer, heard by the observer. So the frequency heard by the observer is actually always higher than the source frequency. If the source is moving towards the observer, because the wave is compressed, lambda becomes smaller. Of course, when lambda becomes smaller, frequency becomes higher. See, you heard a higher frequency of sound. I will show you a simulation later, don't worry. This is just to get you a basic concept. Now, if the source is moving away from the observer, the wave lived by the source towards the observer is more expand. So the wavelength becomes longer. When the wavelength becomes longer, frequency becomes lower. So the frequency heard by the observer is actually lower. So we can compare like this. The higher frequency is like when the source is moving towards the observer, you heard the sound emitted by the source is but when the source is moving away from the observer, the frequency which is lower is lower frequency. Yeah, you heard a lower frequency. Now, if you look at the formulas, okay, look at the formula. Okay, about the formula, I'll leave later on. I just want to tell you about the higher frequency and lower frequency as a result of the motion. We talked about the source already. Yeah, when source moving towards the observer, you heard a higher frequency. When the source is moving away from the observer, you heard a lower frequency. What if now the source is stationary, but observer is moving? Observer either moving towards or moving away. Yeah, VO. What will happen? This thing will happen. Same thing like the source. If the observer, this time, observer is moving towards the source, you still hear a higher frequency like the source moving towards you. It's relative. It's the same. The source moving towards you or observer moving towards the observer, when the source is moving towards the observer or the observer moving towards the source, you always hear a higher frequency. It's relative. It's like you run towards me or I run towards you. It's the same. It's like we both run towards each other. It's the same. Okay? So both you will hear a higher frequency. Okay. What if you're moving away? What if the observer is moving away from the source? So it's same thing like the source is moving away from the observer. You always hear a lower frequency. It's like you run away from me, then I run away from you. It's the same. We are running away from each other. It's relative. It's the same. Yeah, you run away from me, or I run away from you. It's the same case. We run away from each other. Okay, so both is the same. You'll hear a lower frequency. Okay, but this time the wavelength emitted by the source is constant. Why constant? Because the source is stationary, the source is not moving, so it does not compress the wave. The wave emitted is not compressed or is not expand. The wave is constant. So for both cases, if only the observer moving without the source moving, the source is stationary, produce the wave at the same location. Okay, so the wave is not compressed or not expand. So the wavelength is constant for both situations. The wavelength will only change. The wavelength will only change if the source is moving. Okay, even the wavelength is constant, but the observed frequency will still be different. Okay, frequency is what you hear. Okay, frequency what you hear. So if the observer moving to the source, you hear a higher frequency. If the observer is moving away from the source, you hear a lower frequency. Okay, clear about these four situations? Now I show you the simulation. Yeah, this is the simulation with the sound. Okay, it's a very special simulation I find for you. I hope you enjoy. Now, let's make the first situation. Let's look at the first and second situation. What if the source is moving towards the observer and ultimately moving away from the observer? What will happen to the frequency? And also what will happen to the wavelength? Let's see. Yeah? Let's look at the example. The source, I make it moving towards the observer. Yeah, this one, 70. Positive 70 means move to the right. Let's start it. Yeah? Let's start the motion. Are you ready? Okay, let's start and let the sound on. Hear the sound. All right? Beware. You hear that? You hear the higher frequency? You see the wavelength here is compressed? You see that? Now, away from observer, the frequency become lower. Do you see that? Do you hear that? Yes. Again. Again, yeah? Again. Now, let's start and sound on. Yeah, sound on. Do you hear a higher frequency when source moving towards? So moving towards higher frequency. Now moving away, the sound is lower. Lower sound, lower frequency. Okay, good. Okay, let's look at the wavelength again. Yeah, let's look at the wavelength again. Let's start. The source moving towards the observer. You see, the wave here is compressed. When moving towards the wave is compressed, wavelength become smaller, frequency become higher. Now, let's make it moving away from the observer. When moving away from the observer, what happened to the wavelength? Let's look at the wavelength. Yeah, you see that? The wavelength is longer. Expand. And also the frequency lower, but the wavelength is longer. You see that? That's it. That's all. Yeah. That's for the first two conditions. You see, when moving towards, the wavelength is compressed. The frequency you hear is higher. When the source is moving away, the wavelength is being expanded. The wavelength become longer, and the frequency become lower. You hear lower frequency when source is moving away. Now let's hear the third and fourth situation. Let's hear it. Yeah, let's hear it. Okay. Now let's look. If the source is not moving, source is stationary, but the observer moving towards or moving away from observer. Let's look. Yeah, let's look. Now let's make the source stationary. And what happened to the observer? Observer moving towards the source. Okay. What do you hear? Okay. What do you hear? Source moving towards. Source is stationary. Now game on. See, you hear when source is moving towards the source, observer moving to the source, you hear a higher frequency. When away from the source, observer moving away from the source, you hear a lower frequency. You see that? Lower frequency. But you see, again. Start, sound on. You see, higher frequency. Higher frequency. You hear observer moving towards higher frequency. Excuse me. Observer moving to away. You hear a lower frequency. And you see, the wavelength is constant. You see, because the source is not moving. The source is not moving. So the either side. Sorry. So when the source is not moving, the wavelength is constant because the wavelength is not compressed or not expand. Okay, so that's all for the animation. Now let's go back to the notes. Okay, so in a nutshell, when source moving towards the observer or observer moving towards the source, is always higher. It always become a higher frequency. When the source is moving away or the observer moving away, the frequency always become lower. So the keyword is moving towards. For either parties, moving towards always generate higher frequency. Moving away, no matter who moving away, always generate lower frequency. Okay, lower observed frequency. So you see, like this one. The first situation, the source moving towards the observer, so we can expect higher frequency. Okay, and so we also have the velocity of source. Observer has 0 velocity, so at the top we don't have VO, we only have VS because it's only the source moving with velocity, so we only have VS. So This is positive or negative? How to know? We just remember that this. If moving towards, we know it is higher frequency, isn't it? We know it is higher frequency. So if higher frequency, the below here must become smaller. Below here must become smaller. So to make this become smaller, you must minus something so that below becomes smaller. So the observed frequency become bigger. Understand? When this one becomes smaller, because you minus, it becomes smaller. This one become bigger. That's why you must minus instead of plus. Understand? Okay. Now the second one, the source is moving away. The source is moving away. We know the frequency will decrease. So in order to make the frequency decrease, so the below here, we know it is only Vs. Only we have Vs. So do we put positive or negative? The question is, we put positive or negative at below here. If we want to make frequency observed decrease, of course, below here must increase. How to increase? Put positive. Don't put negative. Put positive. You put positive. Then below here become increase. So the frequency will decrease. You plus, so here become increase. Here become decrease. Okay? Now, the next. If the observer is moving towards the source, so we expect the frequency become increase, because moving towards, frequency increase, and we only have VO. VO is at the top. Okay, observer velocity is at the top. So we know we expected the frequency increase. So the top you must make bigger. You must make bigger in order the frequency increase. So to make this bigger, so we must plus. We plus something. If we plus something on the top, the top will become bigger. So this frequency become bigger. Okay, that's why we put positive instead negative. Now the last example. Now the observer is moving away. The observer is moving away. So expected frequency will drop. The frequency will drop. If we want the frequency to drop, we know it only has VO, no VS, only has VO at the top. Okay, so is it positive or negative? If we want to make frequency drop, so the top here must make it smaller. How to make it smaller? We minus, then become smaller at the top, so the frequency will drop. That's why negative, not positive. Okay, that's the rule of positive or negative. Very simple. Just remember, if moving towards, the frequency always increase. If moving away, the frequency always decrease. So whether you want to put positive or negative, depend on whether it's below or at the top. Then you just use your brain to determine the positive or negative. All right. I hope you enjoyed this lesson and stay tuned for the upcoming videos for the real problem solving. See you. Bye. Thank you for your time. Please like and subscribe. Bye.